Most amateur fantasy maps feel artificial because humans struggle to generate natural-looking random shapes. We tend to draw disconnected blobs, lacking natural logic. Actual topography follows precise physical processes. Every coastline and mountain range is the result of specific interactions between land and energy. Geomorphology, the study of how terrains form, provides the framework for building a realistic world. It requires a basic understanding of planetary foundations, rather than an advanced science degree. To ensure believability, construct the fantasy map by simulating a compressed version of geological history. Start by drawing a single massive landmass in the center of your canvas. This unified shape serves as your planetary starting point. This method relies on the theory of continental drift. On a dynamic planet, continents were connected at some point in the deep past, forming a supercontinent before drifting apart. Draw irregular, intersecting lines through this supercontinent, fracturing the shape into roughly 5 distinct tectonic pieces. Spread these fractured pieces across the canvas. Vary the distances between them to map out both massive oceanic voids and narrow channels. Preserving this puzzle piece aesthetic signals realism to the viewer. It demonstrates that the continents belong to the same organic system. Now that the oceans are mapped, shift focus to the invisible tectonic plates beneath the surface. These plates are constantly colliding and grinding against one another. These interaction edges are the logical locations for every major mountain range on your map. When two plates directly collide, their edges crumple and push upward. The resulting fold mountains, like Mount Everest, showcase the immense vertical force of these collisions. Draw long, unbroken ridges along the leading edges of your colliding landmasses to represent these folds. If plates grind past each other, one section of the crust may tilt abruptly upward. This creates fault block mountain ranges, like the Tetons, which rise jaggedly and suddenly from flat plains. Mark these jagged, asymmetrical ranges along the lateral friction lines of your map. These mountain ranges function as the readable collision scars left by your world's tectonic engine. The final interaction is a subduction zone. Here, one tectonic plate is violently pushed completely underneath an opposing plate. This subterranean pressure forces magma upward, creating volatile volcanic mountains like Mount St. Helens. Unlike long boundary ridges, volcanoes often form as distinct solitary conical peaks. Mount Fuji stands as a prime example of an isolated peak set apart from continuous chains. Place these solitary, dangerous landmarks along the trailing edges of the subduction zones on your fantasy map. Mapping subduction allows for the logical placement of the world's most extreme and volatile geographical features. Survey the completed map as a whole. Observe how the puzzle piece coasts and the logically mapped boundary mountains complement each other. The organic dispersal of the final continents now completely hides the original unified circular shape. While the lithosphere is now established, the next major force to carve the map will be the hydrosphere, the movement of water bodies. Anchoring fantasy cartography in the science of geomorphology produces a structurally sound reality.